Here's a problem. We have a work function of 2.5 and they ask for threshold frequency. Now, I didn't talk about threshold frequency, but it should be pretty obvious. Threshold is the point at which an effect begins to take place. And the effect would be when electrons would be emitted. And so the threshold would be, okay, when? Well, when HF equals the work function, that means at that point, that's the threshold, and then electrons could be bounced. And so what we need to do is find HF equals W naught. Now notice that we have given this work function in electron volts, and very common that that's the way it's done. Now that means that to balance this equation and keep our units, we have to put the H, not in joules second, but in electron volt seconds. There's the constant. You'll be given it, times F equals 2.5 electron volts. Now the electron volts will cancel, and I'll be left with my frequency, and it's 6.04 times 10 to the 14 hertz. Now just study that example. It's an easy one. Now this one is a little bit more complex. Lots in this question. Again, the work function is 2.13 electron volts, and they want there's a wavelength in 4.5 nanometers. Now instead of using HF then with frequency, we want to use hc over lambda. That's the energy of the photon equals the kinetic energy plus the work function. You'll always write this equation down. So now we plug in the different values, and since we have to use electron volts, I'll have the electron volts, the H there, times the speed of light, divided by, notice what I put for the wavelength, 4.5 times 10 to the minus 9 meters. There's the kinetic energy, there's the electron volts. Now I solve for the kinetic energy, and I get an answer in electron volts. But unfortunately, electron volts is not compatible then with 1/2 mv squared, because you have to be in joules. So you convert the electron volts to joules, meaning multiply by 1.6 times 10 to the minus 19. And now, only when the kinetic energy is in joules can you set it equal to 1/2 mv squared. There it is. And then the m is the mass of the electron, which would be given 9.11 times 10 to the minus 31st. I then solve for v, and I'll get my answer for the maximum speed of the electrons ejected. And there it is. Now work through this on your own step by step. It's the model question.